Okay, so the discriminant, as you should know by now, the discriminant is a special portion of the quadratic equation. Remember, the quadratic equation is negative b plus or minus the square root of b squared minus 4ac all over 2a. The discriminant is this portion right here, all right? That helps us determine if we're going to have a one real solution, two imaginary solutions, or what did I say? One real solution, two real solutions, or two imaginary solutions. I think I've got that right. But that's not what it's asking for. It's saying, how does the discriminant of a quadratic equation indicate if the real solutions are rational or irrational? Obviously, if you end up in the discriminant, if you end up with a negative number, like let's say you have negative 22, obviously that is imaginary, okay? So that's not a real solution, okay? But what if you end up with, under the radical, how do you know if it's going to be rational or irrational? Remember, rational means can be written as a fraction, irrational cannot be written as a fraction. Some examples of irrational numbers are, well, pi is 1, square root of 2 is 1, so anything that can't be written as a ratio or as a fraction. So the idea here is that if you end up with, under the radical, if you end up with square root of 16, is that a rational number? Yes, because it's equal to 4. How about if you end up with the square root of 15? Not so much. What is the square root of 15? Well, something less than 4, right? Okay, so this is an square root of 15 is irrational. So how does the discriminant indicate if the real number is rational? It's if the discriminant is a perfect square, then it's rational. Okay? Because if you end up with a perfect square, then you can add it to this, divide it by this, and it'll be fine. You'll still end up with a fraction or a rational number.